In this lecture, we are going to learn about the Falloff property and its two modes, the inverse square clamped and the smooth Falloff. And also we are going to see how they affect our compositions, and I will give you a few examples. Let's look at our composition and the layers that I have adjusted here. We will open the P position to see exactly how they are in the Z space. This is my top view, this is my active camera view. The light here is a point light, is a normal point light, nothing interesting, just normal, and it is at -2000 from the Z axis. The near is at -1000, the middle is at 0, and the far is at 1000. You notice that with this light, all layers are illuminated equally to full intensity of the light, regardless of their position in the Z space and their distance from the light. In real life, after a certain distance, the intensity of the light becomes nil. It means it's no more effective and it will not light any object. Let's get this effect of the light dying off or falling off into our composition here. Let's go to our light, double click, and look at Falloff is set to none. If you click, you will notice it has two options, the smooth and the inverse square clamped. The inverse square clamped is like real life. It means the light will fall off according to a certain inverse square mathematical formula that is not so complicated. We choose that option. We notice that the radius is 500. It has been set. We can change it here, but I will leave it to 500. The fall-off distance is off. It means it will not be operating with the inverse square clamped. We click OK. There is quite some change in the illumination of the layer. Let's take our light, press AA rapidly, and the light options will appear. We have the fall-off set at inverse square clamped. The radius is set at 500. Within the radius, every layer is illuminated at full intensity of the light. If you increase the radius, it will increase the intensity on the layer that are within this radius. Let's set it at 1000. So now, since near is within the radius, is included inside the radius, it will be lit at 100% of the full intensity of the light. After the radius, the light starts falling off, and it falls off according to the inverse square clamped formula. Notice that you have to think about the radius as a sphere, not a circle in one plane. If you move the light on the x-axis, for example, you notice that the illumination is no more at full intensity from near because it's no more within the radius, though you moved in the x-axis. If I will undo that, if you move in the y-axis, the same will happen and the light will diminish because the layers are no more within the radius. I will undo this one. Fine. Let's go to the other option. I will double click on the light and I will choose smooth. Now you notice in smooth the radius is highlighted. Let's put it at 500. And the fall-off distance is highlighted and we can change it from here. Notice that as soon as change the radius to 500, all the layers have disappeared or became invisible. I will click OK. Fall-off is now smooth, radius is 500, and fall-off distance is 500. Any layer within the radius will be illuminated at full intensity of the light. The fall-off distance is how far beyond the radius the light falls off. So it will fall off completely after 500 pixels. So any layer within the radius is at full intensity. Beyond that, the light will fall off and will become nil at the end of the fall-off distance, which is 500 in our case. Let's increase the value of the radius, for example, to 1000. You notice how the layer near starts appearing because it is within the radius and the fall-off distance. I will put this one to 1000. Now, you can either increase the radius and then you will have the other two layers within full intensity of the light, or increase the fall-off distance, which makes the light decrease intensity linearly, meaning with a linear effect. I will increase it to 2000, and you notice now middle has appeared, but its intensity is not 100%. It does not fall within the radius, it falls within the fall-off distance, and hence the intensity is diminishing here up to 2000 pixel, maybe here. So middle might be at 50% of the intensity. If I put it at 3000, then far will appear, take it a bit up, because it falls within the fall-off distance. Anything now beyond the 3000 pixel, of course, will not be illuminated. So in short, this is a fake lighting that is useful in motion graphic, and it's a linear effect of the intensity of the light, or the fall-off of the intensity of the light. Thinking of the radius and the fall-off distance as spheres, not circles in one single dimension, moving your light on the x-axis, for example, will change how the layers are illuminated and how the intensity is applied. I remind you that the smooth is a linear function of the intensity and is nothing near reality, but it is very practical in motion graphics. Let's go back to our previous example. We had 3 lights here. These were, I remember well, they were point lights with an intensity of 98%, and they do not have any fall off. Let's delete the middle light. Let's put off the upper light, and we have a single light to work with. This is our first light. If we double click, we notice this is a point. It doesn't have a fall off. Let's put the intensity at 130 and give it a fall off inverse square clamped. You notice how it's changed. It has become more natural. It's like a bulb hanging, and if I press OK, it stays there, and it's like, you know, you have a bulb just floating in above the door. If I open the AA and I increase, for example, the radius, you notice how it's lighting up now more the scenery. If I reduce the radius, but you notice also it's very natural. If I give it a smooth, now I will have to adjust here. Let's put this at 0 just to show you the difference, and it's pretty sharp. Let's reduce it so the light starts from here. Fine. Then we increase the fall off distance depending on what you want. Of course, it's moving off. Now you have like a kind of vignette here. This is dark and this is, you know, illuminated. Quite interesting. Let's change the light from point to spot. Now things here are different. I'm not gonna play with the cone and cone feather. Just gonna take the point of interest and move it up. Right. Put the radius at 300 and just put the fall off distance at 0, just to start the example. You notice how sharp it is. Now if you want more lights here and, you know, diffuse the light later on, you might change the radius, and then you might increase the fall off to see how far you want to reach to the floor of the scene. And you created something very natural here, though it's smooth. If you use inverse square, now the radius has to be increased, and actually this is so realistic. You notice the light is intense where the light is supposed to be, then it falls off very naturally. If you put on the other light, we can do the same and make it a spotlight. Now it's spotting somewhere else. We will move it on the axis. Let's take the point of interest, put it down, move it up a bit. Yep. You notice how when they are intersecting, it is giving you both lights together. Let's make it a inverse square, and here you are with a 500 and 500. You notice it's quite good. Let's remove it, make it smaller. Here you are. You have created quite some scenery here, and you changed everything. Now of course you can make it much better by working on the radius and so on. That's all about light, and I hope you benefited a lot.